Hey everyone, welcome to this new training video series from CAPSS. Today we'll be making a quick introduction to Inovance's PLC and motion control software known as InnoProShot. And we're going to be looking at how you get started and eventually how to get power to a single axis of motion. We'll start off by opening the application and starting a new project. To do this, we'll go over to the New Project button and we'll go over to Standard Projects and drop down to the PLC that we are using in our physical hardware. Today I'm going to be using an AM522, so we just want to add in a name for our project. Test YouTube. And then we can decide on our language that we are going to be using. So you have all of the options listed in the dropdown. For this example, I will select ladder and hit OK. This will kick off the application to load in our device. Once our project environment has loaded, we'll be brought into this screen where we can see the application and the device on the left-hand side. If you're using EtherCat communications or intend to use EtherCat communications, you will have to configure that on each PLC that you open. We can do this by going to the network configuration, so double click, then we can click on our PLC and enable the EtherCat master. As you can see, this will add in an extra section on the left for EtherCat communications, and we have also had extra devices added to the network device list on the right. If we wanted to add Ethernet IP, either master or slave, we can also enable that from here, and relevant devices will appear on the right-hand side as well. Assuming you have all of your equipment wired up and powered on, I personally like to start by ensuring that I actually have communications to the PLC via the device network. To do this, we'll double-click on the PLC itself in the device list and head over to Communication Settings. And here you can see our gateway, which is pre-configured in the application. We can go to Scan Network, which will bring up our scanning. And as you can see, my device is automatically pulled in. By default, the address of every Inovance PLC will be 192.168.1.88. So ensure that you are in the 1 range when trying to connect. Otherwise, you will be met with a blue font, and it will be in diagnosis mode, which means you will not be able to go online with the PLC. If you have multiple PLCs in your network, you can wink each individual device, which will just flash some lights. Now that we've got our correct device selected, I'll hit OK, and that is our pathway complete and set. Now that we have our pathway set, I personally like to go online and download an empty project just so we know that the PLC communications is all good. So we'll do this by logging in. At the very top here, we have a login button. You can alternatively use the shortcuts if you like that. So we hit login, wait for the PLC software to communicate. If you already have an application on the PLC and it is in run mode, it will ask you to stop the PLC if the changes you are making are too much to be able to do an online login with download, for example, or if your project name is different to the one on the PLC. So in this case, we'll hit yes, and we'll let that transfer across my blank project. As we can see, the project has been downloaded and we are online with the PLC. However, it is in stop mode by default every time we download a project. So we know that communications is okay, and the PLC now has a fresh blank project on it for us to work with. So we'll go back offline by using the logout button up here. Since we're using a single axis of motion in this application, I will either have to manually add that axis by right-clicking EtherCat and going to Add Device, or we can alternatively, now that we have our project path set, do Scan for Devices. So to do this, we have to be offline from the PLC. So at the moment, we're offline. We right-click EtherCat and do Scan for Devices, which will bring up our Scan for Devices window. Simply click Scan Devices at the bottom left, which will ping the EtherCat network and show us the devices that are in the EtherCat network. If I had multiple that were daisy chained together, powered up, and wired in, we would see all of those add into our list. From here, I just want to copy all to my project, which, as you can see, drags in both an axis drive and an axis of motion. In the drive screen, we can see all of the settings for the actual drive itself. So address, clocks, etc., etc. The things that we most care about, however, are in the individual axis for the motor, which are things like scaling, the use of incremental to absolute encoders, what kind of velocity ramp modes, and dynamic limits for CNC, and so on. However, we will not be covering this today, and we will cover it in a further video. We can begin creating our first program. So in the template that we created when we opened the first project, we dragged in a simple ladder logic program. So in our application list, we can look at the PLC program, which is the default name of the first project. In here, we can see our environment with our rungs and our toolbox on the right, which will show what instructions we can use in this environment. For this video, I'm only going to be showing the use of ladder logic because it's a great starting point for beginners to either just programming or to code assist environments. It just wraps everything up into a nice package and is very easy to understand. If we wish to add new programs, which can either be extra ladder logic ones or another programming language, we can right-click the application, go to Add Object, and then drop down to POU. From here, you'll see we're able to select either a program type of program, function block, or function. So if you wish to create your own function blocks using a combination of pre-built function blocks so that you don't have to repeat the wheel every time, you can go ahead and do that. As you can see, your options here are just like we saw in the template. So if you wish to make a CFC or a structured text, be my guest. But for this example, we'll be staying with the ladder, so we'll cancel out of this. If we wish to add new networks or rungs to our project, we can go to the top toolbar or go to the toolbox to the right. Really depends on what you wish. So I'm just going to throw in a couple of networks, and we can start adding contacts and coils to our heart's content. Selecting the correct area for coils, etc., etc. Again, in this example, all I'm going to do is switch a single motor on. So in my application, I want to add in a single MC power. So we'll go over to our motion control in the toolbox on the right and go to point to point, and we can see our MC power. You can either select the network and double click MC power for it to go across, or you can drag and drop. So if I wanted to drag, you see I get a number of options as to where I can put them, etc., etc. When adding in a new function block, they must be declared because they are their own instances and data types. The CodeAssist environment has an auto declaration. So when we enter here and click enter, you see our auto declare will come up. It will show us the scope of which this variable will be declared, a name that we want to give that actual variable. You can see the type, which is automatically filled because it knows it's going to an MC power function block. We can give an initialization value, an address, comment, and decide if they're going to be constant, retained, or persistent variables. In this case, I don't want to change anything else, so I'm just going to hit OK. And that variable will be declared, as you can see in the top. Now that we have our MC power function block in our logic, we need to designate which axis it will be controlling. As you can see, the name of our axis connected to our first drive is axis. So I will go ahead and click here and enter in axis, which you could see would autofill. And then we have axis filled out there. Now we can fill out the rest of our function block inputs. As you can see, this function block is an enable input and so needs a continuous true signal to allow for MC power to continuously work. If this was an execute signal, and it had a one-shot input, it would take a snapshot of the rest of the inputs and execute that function block a single time until you see the status is complete. So in this case, I will leave my enable input as it is, because this is always going to be true according to ladder logic. So in this case, I just need to give a variable to my regulator on and my drive start. In this MC power case, regulator on will be controlling the state machine for the EtherCat comms. However, I always find being lazy helps, so I use a single variable for both of them and throw them both on at the same time. Like so. And for outputs, I don't really care about any of the other regulator or busy or errors, so I'm only going to give something to our actual status of the motor itself. So for this, I'm going to throw in a coil on the end of it, and I'm going to feed that into the logic here. The purpose of this is just to give internal logic and get you working with ladder logic and understanding how internal variables are working. So for this, I'm just going to do test out auto declare. Again, as you can see, auto filled as a Boolean type. And I'll use my test out here. Delete the second one. Test. Do. And there we go. We have some logic. Now that we have variables for everything, we can check our logic. So we're going up to the build, which will build our application and give us a list of no errors, no warnings. This is just check the local application. So to build the entire project, we do check application, which builds everything in the PLC. As you can see, only 5 messages, no warnings, no errors, so we're all good. Something that's very important with anything that is using EtherCat communications is that it must be in the EtherCat task to be able to execute commands to an EtherCat device. So in this case, because it was our default project, you can see it's gone straight to the main task up here. However, because we will be controlling an EtherCat device with the MC power function block, I need to move that task into the EtherCat task. So we'll bring it up here, drag it to the EtherCat task. It's very important that you drag it to the EtherCat task itself or just below here, because if you drag it above the EtherCat task, you will get compilation errors. So now that it's been moved to our EtherCat, we'll compile again, build the application, make sure that there's no errors. We get an extra warning just to say that main task isn't doing anything, but other than that, we're all good. If we wanted to configure our tasks, we can go into each of them individually and set our cycle times as well as their types, so they can be interrupts, etc., etc. And you can go down to real accurate measurements of timing here. If you wanted to do the calls manually, rather than dragging them to each of the programs, you double click on them and go to add call and do it that way. But I'm lazy and I like to throw it in by dragging it. Much more fun that way. Now that we have a PLC program logic and we have it defined in a task which will actually interact with our motor, we can go ahead and do a download and get ourselves running. So to do this, we go back to login, which will connect us to the PLC and do the checks of if the project is different or not. In this case, it's detected as different, so we'll hit yes on our application stop. So that will hold the PLC and stop it from running, and download our project. As you can see, our project has finished downloading and we are now online with it, but our PLC is in the stop mode, which is denoted at the bottom here and at the top with the play button being highlighted. So to start the PLC, we simply hit the play button or F5 if you like shortcuts, and we can see the status of our PLC start to change to green. And if your wiring and configuration is all correct, the most important thing is your EtherCat status turn to green as well. If you have any kind of configuration errors, i.e. scaling or parameter files, that kind of stuff, usually your drive will kick in, but your motor will not kick in to be a green healthy status. So now that we're online and the PLC is running, we can go ahead and start modifying online values. As you can see, we can see immediately what is true and what is false. So we can start modifying values from here. To do this, we can double tap and you can see it sets my prepared value to true. So that toggle of the bit hasn't actually gone through to the PLC yet. I've just told it prepare for a true value. So if I go up to here, you can see there is a write values or another shortcut for it. So if I do write values, you can see my prepared value has actually gone into the live value. And then my MC power function block internally has gone and worked. And my status of the motor has come high. And you can see the rest of my outputs correspond. And my own logic internally has activated as well. So just like that, 10 minutes, nice and easy. We've got a motor configured, dragged into the project, dragged into the logic, up and powered. And it's that simple. So that's all I'm going to be covering in this video. Just a very quick one to get you up and running for motor power. But in the future, I'm going to be covering many more things, such as advanced motion control using gearing and camming, maybe some linear flying shears and some group control. But mostly main things like variable definition, global variables, HMI interaction. So keep up with the channel and I'll see you around. Ciao.